Hi ladies and gentlemen, this is Mr. Green again. This is another in my series of AP statistics videos. What we're looking at now is we're doing the last topic in Unit 8. The only thing left is a review, and I'll be doing that during the Class Connect time frame. We're looking at the distributions of means. We're looking at two means, but now we're not going to try to match them together. They're going to be independent of each other. Two independent means. So what are we doing here? Well, we're doing this right here, again, okay? We're still doing this. We're calculating the t-distributions, okay? We did a single sample mean, and we're doing some two sample means, both matched and unmatched, okay? So, matched pairs, the data is related to each other, okay? You're getting one variable that you're trying to figure out between two people, two groups of people that you can match up to each other, some sort of relationship between them. With independent data, you might not even have the same number of samples in your two samples. One is not dependent upon the other one, okay? So this would be a good way to test for things where you have different sample sizes that you're comparing against each other, okay? You should always try to show normality with these type of things, because if it's not normal, it's going to be a real hardship on us here, okay? And so we're going to be looking at the size of n to make certain that it's big enough. Remember, about above 20, we're going to be looking, saying it's pretty much going to be a normal distribution. Otherwise, show a histogram or a box plot of the data. So for both samples, to show independence, you need to make certain that they will side note. S bars will tell you if they have the same standard error. If you calculate and put the data in, when you calculate the statistics for it, the one variable statistics for each one of them, you'll be able to look at those S bars and see if they're the same number, to see if they have the same standard error. Now the book goes into the lessons that you go through go into quite a bit of work about having the same sample size and doing a pooled thing. Very rare. Don't even attempt it. I mean, you might see it in this course, but you're not going to see it on the AP statistics test. They're going to tell you don't do it. Okay? So, we're going to construct confidence intervals for the two population standard means. Very important caution here. When you're taking the test, if you use the calculator and you write in the numbers in there, you got to make certain you show them that you know how to calculate it. Okay? You're taking the t times the standard deviation of this information. This is the square root of one S bar divided by its sample size plus the square root of the other S bar divided by its sample size to get this range. If you don't do that, you will have all sorts of little incompletes on it. So this is taking the X bars plus or minus t times that, okay? Write that type of information down on the test, showing that you know how to use the formulas. By the way, pretty much this formula is in the formula charts, but you got to put the values in there to make certain you're showing them how you got it. You don't do it, incomplete. They don't think you know what you're doing, okay? They just think you're punching buttons on a calculator and getting lucky. So you've got to make certain you give them that information. Okay, we're going to compare a new method of teaching reading to slow learners to the current standard method. You decide to base this comparison on the results of a reading test that's given at the end of the learning period of 6 months. So we're going to take 6 months. We're going to take a random sample of 20 slow learners. 8 are taught by the new method. 12 are taught by the standard method. All 20 children are taught by qualified instructors under similar conditions for a 6-month period of time. The results of the reading test at the end of the period are given here. There are the new method results. There's the standard method. They want us to use a 90% confidence interval and interpret the interval for true mean differences between the test scores for the new method and the standard method, and test to see if the new method's test score is higher using an alpha of 0.1. So, first things first. Are the two samples matched? No. You can see we don't even have the same number of sample sizes in them, right? We got 8 in one and 12 in the other, right? Are the two samples independent, and are they simple random samples and normally distributed? Well, they said they were random samples up here, so we're going to assume the simple random samples. Are they independent? Yeah, they're not the same children, so they're not going to be dependent upon each other in any way, shape, or form. So the only question there is, are they normally distributed? So I keyed them in and got my one variable statistics for both of them. I note that my S bar is 4.8 here, and my S bar here is 6.3. So they're not the same that way. So that whole pooled issue goes away, and we don't have to worry about that. Good? Got it. So I then looked at the graphs of them and drew the graphs out. And here's my histogram for the first one and my histogram for the second one. And oh my gosh, what's that? That's an outlier. Having an outlier in this data tells me that we've got a problem. Okay? So what am I going to do? I'm going to go through the data, take that outlier out, recalculate my one variable statistics right here. Okay? Because now I've only got 7 of them in there. And this is my new graph, my new box and whisker. Looks fine at this point. So now the graphs are looking a little bit better. Is this the correct method to take that out? With an outlier in it, probably shouldn't be doing a 2T test here, but because it's going to give us some really skewed results, I think. But for the purposes of teaching you how to do it, I'm going to go ahead and do this, okay? So I'm doing a 2 sample test, okay? And I'm going to get a range, a data range here. Let's see if I show you this over here. Okay. So what I'm doing is I did a 2 sample t-test. Now, where do I find that one? What's in here under stat tests? And it's down here, number 4. Okay? And it asks for it either as data or as statistics. I think I used statistics on this one. It won't make a whole lot of difference. You just key in the X bar, the S bar, and the N. X bar, S bar, and N. And as you key those things in here, okay, and it asks you, what are we comparing? Are we comparing for the mu's to be uh, mu1 to be not equal to mu2, mu1 to be less than mu2, or mu1 to be greater than mu2? And in this situation, we're wanting to see this one over here, mu1 greater than mu2, okay? Because we want to see that the test scores for the new method are higher than the old method, okay? Are we using pooled data? And I'm going to say no, we're not using pooled data because our S bars are completely different. And so we're going to go ahead and calculate that. And I didn't do it there because I didn't have the data in it. But you can see I keyed in that information here. And that's what I got as a I stopped talking there for a second. I know. That's what I got as a interval right there. Okay? 90% confidence interval. And you can see my X bar here was, where is it, 78, and that's what I keyed in right here. My X bar here is a 72, and that's what I've got right there. My S1, X, uh, S of X1, S of X2 are right there. Those came right off of these sheets right here. Okay? So I'm taking these right off of that, and that's how I got that confidence interval. Cool? So we got that confidence interval. Well, by looking at the interval, we're 90% confident that the difference in the mean scores of tests after the 2 methods of teaching is between 2.9 and 9.9 with a 14.2 degree of freedom. So I'm pretty certain that since 0 is not in here, it has to be higher, doesn't it? Why do I say that? Because look, if they were the same, 0 would have been in my confidence interval here. They're not the same. So it's between 3 and 10 points higher. I rounded there a lot. Okay? So it's between 2 and 9.86, whatever. We are talking about a difference. So we now want to make certain that we do have a difference here. Okay? So we're going to do a hypothesis testing. We're going to say H sub naught, that the mu of the difference, or that mu of the new method will be greater than mu of the old method, but I just use as mu as the difference is greater than 0 at an alpha level of 0.1. So having this information here, so we're going to do a two-sample t-test. Okay, I used the L1, L2 because I'd actually keyed them in, did that information, and when I do that, and I'm looking for mu1 greater than mu2, since my probability here is less than alpha, right? A lot less than alpha. I would reject H0. Okay? So the new method's test score are not higher with a 90% confidence, but the sample size is awful small in this situation. You can see I put the caveat in here. Anytime you have anything that you're questioning, you need to make certain you say it in there. I probably should have said sample size is small, and we did have one outlier that we eliminated. Okay? So since my probability is less than A, randomness happens. Okay? So I appreciate you guys making certain you're always telling me that you're in AP statistics. Confused by this? Don't worry about it. Sometimes it's confusing. Come and ask questions in the tutoring. Make certain you're understanding how this is going. Okay? Make certain you know how you're going to answer these questions on an AP statistics test. I appreciate your time, and I'll look for you next time.